Good afternoon all. Welcome to our online learning session. Today we are going to see standard 9 Maths 2 lesson number 2, that is parallel lines. So last time we had done the 2.1 exercise. So now we'll see 2.2. But before that we'll do some theorems. Now we'll see use of properties of parallel lines. So by using the property of parallel lines, we are going to prove the theorem that sum of the measure of all angles of a triangle is 180. So it is there on page number 18 of your textbook. This is the use of properties of the parallel line. So the theorem is the sum of measure of all angles of a triangle is 180 degree. Now for this, draw a triangle A, B, C. Now given, what is given? That triangle ABC is any triangle. So in given you will write triangle ABC is any triangle. Now see, to prove, we want to prove that sum of the measure of all angles of a triangle is 180. Means measure angle A plus measure angle B plus measure angle C is 180. But don't write just A, write the full name. So here you will have angle ABC plus angle ACB plus angle BAC is equal to 180 degree. Now see, angle ABC, angle ACB, these two are done, angle BAC, third one. So all the sum is what? 180. So here you will have a construction. Here you have to draw, and writing short in that full form over there. Now see, here you have to draw one line parallel PQ. This is A. This PQ is parallel to BC. So in construction, write down, draw a line parallel to segment BC and passing through A. See, you are drawing a line parallel to BC and it is passing through A, such that, see how are the points over here, such that P dash A dash Q, that means A is between P and Q, such that you will get P dash A dash Q. Now see, for proof, see here, line PQ is parallel to BC, and if you see AB is the transversal, and here also if you see AC is the transversal. So for the first point, when if AB is when PQ is parallel to BC and AB is the transversal, here you will get Z, that is alternate angles. So these angles you can show congruent. When PQ is parallel to BC and AC is the transversal, here you are getting a reverse Z. So these two will be congruent alternate angles. So we'll write first this. So what you will write? See, line PQ. Line PQ is parallel to line BC and line these two angles are same. So angle PAB is congruent to angle ABC. Reason you will write alternate angles. Now these two are parallel again and AC is the transversal. So you will write here line PQ is parallel to line BC and segment AC is the transversal. Now when you are writing AC is the transversal, see these two angles you are getting the corners of a Z which are alternate angles. So again they will be congruent. So you will get angle QAC is congruent to angle ACB. Here you will write alternate angles. Now this is 1 and this is 2. See here what we want here, ABC plus ACB plus BAC. Now see ABC and ACB it is there, two are there, but what is there in between? Plus sign is there. So how you will get that plus sign? You will add 1 and 2. So on adding 1 and 2, see what we will get. And make the figure again. So here we wanted to prove angle ABC plus angle ACB plus angle BAC is equal to 180 degree. This we have to prove. So the triangle I will make again ABC, and you have to draw one line parallel to BC, that is P and Q. So these are alternate angles over here, corners over there, these are alternate angles over here. Now if you see, now you have to add 1 and 2. So here you will get adding 1 and 2. Now when you add 1 and 2, what you will get? See, angle PAB plus angle QAC is equal to angle ABC plus angle ACB. So we will arrange this properly. Angle ABC plus angle ACB is equal to angle PAB plus angle QAC. Now if you see over here, it is ABC is there here, ACB is there. What is not there? BAC. So what you will do? Add BAC on both the sides. So you will get adding angle BAC, name this as 3. Adding BAC to both sides of equation 3. So this is equation 3. Now see here, it will become ABC plus angle ACB plus angle BAC is equal to, here you will get angle PSB plus angle QAC plus angle BAC. Now if you see over here, PAB, see angle PAB and BAC, bring them together, so you will get angle PAB plus angle BAC. See, PAB and BAC, you are getting this bigger angle PAC, and this remaining QAC you have to write here QAC. Now if you see this, what you will get? Angle PAC plus angle QAC. Now if you see angle PAC and QAC, now your reason, here you can write, since here for this you can write, since how you got PAC, so you will write an angle PAC is equal to angle angle TAB plus angle BAC. So there is reason you have to write that on adding you are getting angle PAC. Now if you see PAC and QAC, this bigger one and this one, if you find these are nothing but angles in a linear pair, so their sum will be 180. So this sum it will be 180 degree. Reason you will write angles in a linear pair. So they are forming linear pair angles. So the sum will be what? 180 degree. Therefore finally what you will get? Angle ABC plus angle ACB plus angle BAC is equal to 180 degree. That only we wanted. So here we can write hence true. So this way, this theorem, that is the use of properties of parallel lines, we have proved that the sum of all angles in a triangle is 180 degree. Now we will see few more theorems. Further, test for parallel lines. Test for parallel lines. Whether given two lines are parallel or not can be decided by examining the angles formed by a transversal of the lines. So how to tell that the two given lines are parallel? So by the angles formed. If the angles are formed, then the two lines will be parallel. Now first one, if the interior angles on the same side of the transversal are supplementary, then the lines are parallel. If interior angles are supplementary, which are on the same side of the lines, then they are parallel. If one of the pair of alternate angle is congruent, then the lines are parallel. If one of the pair of corresponding angles are congruent, the lines are parallel. So these are tests for parallel lines. So in this we will see two theorems on alternate angle test. So this is alternate angles test. Now see here, we will draw two parallel lines and one transversal, that is N. Here it is L and N. So this is A, this is B, and consider this as C. So this diagram you have to make. Now see here, corners of a Z, A and B, alternate angles. Now if you see over here, the theorem is, if a pair of alternate angles formed by a transversal of two lines is congruent, then the two lines are parallel. So we write, if a pair of alternate angles formed by a transversal of two lines is congruent, then the two lines are parallel. See, if the pair of the alternate angle which is formed by two parallel lines and one transversal, if you can show that they are congruent, then the lines will be parallel. So this is the alternate angle test for parallel lines. Now you have to write here given. Now see in the figure what it is given. It is is not given that the two lines are parallel. N is the transversal. So here line N is the transversal of line L and line N, and angle A and angle B, A and B is a congruent pair of alternate angles. So angle A and angle B is a congruent pair of alternate angles. And that is angle A is congruent to angle B. See, angle A is congruent to angle B. So how we will show further? We'll see the proof over here. Now see, now can you see some angles in a linear pair? Now see, angle A and C, they are in a linear pair. Linear pair sum is how much? It is 180. But A is equal to B. But A is equal to B. So what will come? Here you will get this sum is 180, B and C. If this sum is 180, then they are what? Interior angles. If they are interior angles formed by two lines and one transversal, that means these two lines are parallel. So we will write the theorem. Now first we will write angle A plus angle C is equal to 180 degree. Here you will write angles in a linear pair. Now further, you know that angle A is congruent to angle B. That is, angle A is equal to angle B given. You see, from 180 what you will write? Angle B. See, A is equal to B. So here you will write B. So angle B plus C is equal to 180 degree. If you want, you can write this 1, 2. And here you can write from 1 and 2. So angle B plus angle C is how much? 180 degree. But B and C are what? Interior angles. So the two lines will be parallel. So here you can write that angle B and angle C are interior angles on the same side. On the same side of the transversal. Therefore, line L is parallel to line M by interior angle test. Here we have shown that they are interior angles. We have shown that they are interior angles. So, by using alternate angles, we have shown that. See, alternate angles given. So that is why it is alternate angles test. By using alternate angles, we showed that the interior angles are congruent. So the two lines will be parallel to each other. So this property. So what you will write further? This property is called in our alternate angles test. This property is called alternate angle test of parallel lines. So this is there on page number 20 of your textbook. You can refer that. A and B are alternate angles over here. We took here angle C. Now by using this, we knew that A and C are in a linear pair, so their sum will be 180. But A was congruent to B because alternate angles. So from 1 and 2 you will get that B plus C is 180. 180 means supplementary and they are interior angles. So you got that interior angle sum is supplementary. Therefore line L will be parallel to line M. So further we will see. Now there is corresponding angle test. So we make the diagram over here. This is the M. So here they are corresponding angles. So A and B, they are corresponding angles. But you need your angle C for proving the theorem. So here you will get L and M. So now we have to write the theorem. So theorem is, if a pair of corresponding angles are angles like a staircase. If you step over here, next you will step here. So your corresponding angles are A and angle B. Corresponding angles formed by a transversal of two lines is congruent, then the lines are parallel. Like how we did for the earlier theorem. Then the two lines are parallel. So your B1 will come. You know that the line N is the transversal and you know that A and B are congruent angles because they are corresponding angles. So you will write line N is the transversal of line L and line N. Angle A and angle B, they are pair of corresponding angles, so they will be equal to each other. They are a congruent pair of corresponding angles. So what we will get, angle A is equal to angle B. Now what we want to prove, that line L is parallel to line M. Now how we will start the proof? See, angle A, it is easy. Now see, first take linear pair combination. Now angle A plus angle C is what? Angles in a linear pair. So their sum will be 180. But if you see that A is equal to B, so what you will get, C plus B is 180. So here again you will get that interior angle sum is 180. Therefore the lines will be parallel, like the previous one only. So here we will write angle A plus angle C. See, they are in a linear pair. This term is 180. So reason we will write angles in a linear pair. But what you know, that angle A is equal to angle B. They are corresponding angles. We have written that in given. So from 1 and 2, what you will get? You will get that angle B plus angle C is equal to 180 degree from 1 and 2. But if you see this, these are interior angles. So as these are interior angles on the same side of the transverse, so these two lines will be parallel. So write down what you will write. Angle B and angle C are a pair of interior angles on the same side of the transversal. Therefore, the lines will be parallel. Now here you will get therefore line L is parallel to line L, and the reason you will get interior angle S, and this property what it is known as corresponding angle test for parallel lines, and this property is known as corresponding angle test for parallel lines. So both the theorems, if you see, it is easy. You can try this at home. Now, if you see practice set to come to, in that, see the first term in the figure. Then given y is equal to 108, x is equal to 71 degree. Are the lines M and N parallel? This is the first question. So here we have two lines. Here it is M and N. And here you have L. This is X and this is Y. Now see here, we have to show that the lines are parallel or not. So see here, both the values are given. If you add these two and you are getting 180, so it means these are interior angles, so the two lines will be parallel. But you have to add and see. If it is not coming there, it will not be parallel. Now see solution. What they are given over here? Y is equal to 108 degree, x is equal to 71 degree. So what you will do, angle x plus angle y. much it will come? See here, 108 plus 71. So it is coming 179 and it is not equal to 182. So as it is not equal to 180, so it is not satisfying the property of the interior angles that their sum is 180. Therefore, these two lines are not parallel. So here you will write line M. Don't forget to put here therefore signs. So here you will therefore line M is not parallel to line M. As it does not satisfy interior angle test, because here it is failing the interior angle test. It should have been 180, but it is not 180. Interior angles test for parallel lines. Now you see further the second one. Now in the second one, they are given if angle A is congruent to angle B, then prove that line L is parallel to line M. Now see all what structure they are given over here. They are given these two lines. Here there is a transversal line. This is A and this is B. This is M and this is N. Now, if you see in this structure, in this figure over here, they are given that A is congruent to B. See, A is congruent to B. Now, how you will do this? Now see here, as A is congruent to B, you will consider one more angle over here, that is C. Now see, A is congruent to B. Now these are exterior alternate angles over here, A and B, that is why they are congruent to each other. Now A is also, see, A is congruent to B. A is also congruent to C. Why? Because vertically opposite angles. So what you will get? That B is congruent to C. And B and C are what? They are corresponding angles. Therefore, you can show that line L is parallel to line M by corresponding angle test for parallel lines. So here we can write. Now see what you will write. Consider angle C as shown in the figure. Now see what you know. You know that angle A is congruent to angle B. So as it is congruent to angle B, that is what? It is B. But as you have taken this C over here, you will get angle A is congruent to angle C. This is 1 and this will be 2. Why this is vertically opposite? See, they are vertically opposite angles. Now see, from 1 and 2 what you will get? From 1 and 2. You will get B is congruent to C. Angle B is congruent to angle C. Now, if you see B and C, they are corresponding angles. So corresponding angles you are getting congruent. So when corresponding angles are congruent, when there are two parallel lines and one transversal cutting them and forming those angles. So here B and C are congruent. This shows that L and M are parallel by corresponding angle test for parallel lines. So here you will write, therefore line L is parallel to line M. Reason you will write corresponding angles test for parallel lines. Further, we will see the third one. You see the third one. These two are parallel, three parallel lines are parallel, but we have to show that. See, here it is B. So here it is X. This is Y, and this is A. We have to, what they have given over there, that angle A is congruent to angle B, angle X is congruent to angle Y. Prove that line is parallel to line N. We have to show that this line N is parallel to line N. Now see, first of all, if you see over here, A is congruent to B. Now if you see there, A is congruent to B, they are corresponding angles. If you see over here, they are corresponding angles. This is K it seems. That is K. Now see, these two angles are congruent. When these two lines are parallel and this is the transversal over here, these two angles you are getting congruent. Even X and Y, if you see, they are congruent because they are forming a Z. They are alternate angles. So here, when you show these two are parallel, when you say that these are corresponding angles, means what? Why they are corresponding angles? Why they are formed? Because L and M are parallel and K is the transversal. So what you will get? L and M are parallel to each other. Now take X and Y. Now X and Y are alternate angles. Why alternate angles? Because M and N, you will find they are parallel to each other and this is the transversal. So here you will get L is parallel to M, M is parallel to N. So finally, ultimately you will get that L is parallel to M because M is common to both. So this way you can show that they are parallel. So we write this. So for proof you will write down angle A and angle B are corresponding angles. They are corresponding angles formed by two parallel lines which are the lines L and M, and K is the transversal. See this, the line K and transversal K. So you will get angle A is congruent to angle B. Why? Because these are corresponding angles. Therefore, you will get, see this is already given over here. So you will get therefore line L is parallel to line M. Why? Because of corresponding angle test for parallel lines. So then you will get corresponding angles test for parallel lines. They have not given that line L is parallel to M, but they have given this these two are congruent. But you should know that these two are corresponding angles, and when they are congruent means what? These two lines are parallel. So we have written that angle A and B are corresponding angles formed by two lines L and M and transversal K. So this is given that A is congruent to B. So A is congruent to B means it is given means those are corresponding angles, means these two lines are parallel. So line L and M are parallel. So you will write corresponding angles test for parallel lines. Now further, if you see X and Y, so angle X and Y are what? See, they are forming the corners of a Z. So they are alternate angles. So here you can write angle X and angle Y are, this you can give as 1. You can name it as 1. So angle X and Y are alternate angles formed by, same way you have to write, formed by two lines. Now see, they are not formed by L and M, they are formed by M and N. So two lines M and N and a transversal. That transversal is not K because here it is some different transversal, that name is not there. So write and a transversal. So what you are getting, therefore angle X is congruent to angle Y, this is given. So why you will, now you are getting as it is congruent, so what you will get, therefore line M is parallel to line N. This is true. Reason what you will write, alternate angle test for parallel lines. So here you will get, because those are alternate angles. Alternate angle test for parallel lines. Now see, from 1 and 2. From 1 and 2 what you will get? 1 you are getting N is parallel to M. 2 you are getting line M is parallel to N. So ultimately you will get that line N is parallel to line N. That is only we wanted to show. So what you will write? See, from 1 and 2. Line M is parallel to both two line M and line N. M is parallel to L also, and M is parallel to N also. Therefore, you will get that line L is parallel to line N. So therefore, line N is parallel to line N. So I hope you have understood this. Please try the theorems at home and try to solve the sums. Thank you.